I like how Carnivore keeps posting the same picture.
Yeah, left lane. That's just refraction left lane.
Sea level means curve.
In planar surveying, elevations are the same in geodetic surveying. Elevations are the height above the geoid. So by adhering to elevations, you're adhering to one either NGVD 29, NAVD 88, or they're slightly different. So the elevations are based on geoid because that's a definition of elevation. And in planar surveying, elevations are exactly the same as in geodetic surveying.
Shoebill, wait, real quick. I'm gonna post this for you because I don't know if you were here earlier. We're talking about Lake Pontchartrain Bridge, right? I'm gonna tag you in this. You tell me where they reference a geoid at all.
If it displays elevation is referencing the geoid.
Okay, show me where it shows that in those as-built plans I just tagged you in.
MLW.
Yeah, mean lower water.
Not a geoid.
Yeah, that's called mean lower water. That's an elevation.
Not a geoid, though, right?
All elevations are based on geoid by definition.
Nope.
Fundamental.
Not mean low water. National title datum epoch. They take 19 years. They use a gauge to basically show the height of the water, right, over a 19-year period, and use that every 19 years.
Why does it have to be 19 years?
I don't know. That's what they decide to use as an interval.
Why don't you?
I'm not Noah.
Why don't you figure that out?
Why don't I figure that out?
There's a reason.
Okay, what's the reason? If you know it. If you know the reason, why don't you just tell the room?
Is it tidal influence?
Exactly.
Yeah, it takes 19 years for the whole cycle to repeat so that you actually get a decent average.
Yep.
Okay. What does that have to do with the geoid?
The 19-year lunar cycle from lunar standstill to major and minor.
So nothing to do with the geoid.
Nothing to do with anything.
No, because tides follow moon phase. Tides follow moon phase.
Just pointing to something totally non-relevant.
Yep.
I mean, it's sort of non-relevant. I mean, but it kind of is relevant because you don't even know why things work the way they work.
So
you just don't know how to answer the question, so you're pointing to something else to try to get a gotcha.
Yeah, so when Shoebill points out all elevations reference a geoid, wrong, incorrect, sir.
Well, the geoid was made to match MLW pretty closely, so
irrelevant.
In a way, they do. Oh, that's irrelevant.
The geoid was made to match it.
Yes.
That's weird. I figured they would just use the actual measurements to make the geoid.
Big Daddy Fleur, if you're hot miking.
So yeah, in order to create the first geoids and everything that we use and orthopedic measurements, that we we had to build these datums, and then we made geoids based off the datums.
So calculated, not measured.
I mean, what's the difference?
There's a big difference.
The difference is you calculate it assuming a globe, and measurements would actually be the real representation of what's there. That's the difference.
And the calculations are based off of the measurement.
No, they're based off an assumption. Uh-oh.
Yeah, uh-oh.
Uh-oh.
Yeah, uh-oh. You guys have nothing.
You guys literally have nothing.
But you could say that. You just keep saying that, and there's tons of shit that represents nothing.
We have nothing. Just all engineering, all modern construction. We got nothing except for that.
Well, so did we agree that if water was curved, then the bridge also would be curved?
Of course not.
Incorrect.
Why would they agree on something like that?
Yeah, who cares? Yeah, we're honest. You guys aren't. So yeah, you're going to get the honest answer. That's our point.
Finally, it only took half an hour. It only took half an hour for finally someone
I just came on, so
you guys just moved the goalposts
you guys have been honest the whole time, though, right? You guys
Oh,
haven't.
so you're unaware
It's
that
Not even
allowed to
true. I
go
told
further.
Jesse. I told
an
Jesse
hour
20
ago.
minutes ago that if if the bridge was the same level, it could be curving or whatever. The water could be curving. So it's not even true, dude. I don't know if you weren't
Weird.
listening or what, but
Who'd have thought?
Point is, though, Jeremy, and next time you hear anybody say Lake Pontchartrain shows curvature, call them out on it, because it doesn't.
It looks like it does.
Oh, it looks like it does.
Oh, it looks
Therefore,
like
it must be. It must be.
Yeah,
A,
we can see
must be a
curve from the
ball.
surface now. We
Hey, look
can't
at
see
this.
it
Yeah,
from
Oh,
curve. Yeah, I see, I see straight lines as straight, and I see curved lines as curved.
Don't forget
The
what you
ocean
say,
looks
Left
flat.
Lane. You can't trust your eyes.
The ocean looks flat, therefore it is flat. The ocean looks flat,
Yeah,
therefore it is
left lane.
flat.
That's just refraction.
The
Left
bridge
lane.
looks
That's what
curved,
that is.
therefore it is curved.
Yeah, it's just refraction though. So, we're good.
somebody
If it's curving,
I was
if it
saying
is
that
curving, what's the rate that's curving? What'd you measure the drop over the distance? What did it just happen to be 8 inches per mile?
Yeah, radius was 1,800 miles. It's a good one.
I like how Carnivore keeps posting the same picture. Oh, that must be Earth curvature. If that was the rate of curvature, if that's the bridge showing a rate of curvature, you guys would live on a small ball. Extremely
What are you
small
ignoring?
That's
ball.
because
That
Whoever
it's
is
highly
trying to drive
zoomed.
over that, like, how are
I
you
mean,
even driving over that
no,
bridge?
why do y'all not mention the fact that that's highly zoomed in from a long way off, and it exaggerates the curve?
So
Oh,
it's
for
not
sure.
the actual Earth curvature. Thank you, Left Lane, for the concession.
No, foreshortening doesn't.
I don't know. Is that dishonest?
Foreshortening doesn't
I didn't say
create
dishonest. I said concession.
doesn't
Go ahead,
create
Jesse.
doesn't foreshortening doesn't create curve that's not there. It just makes it more apparent by eliminating that large aspect ratio of the curve.
Yo, can you define that? I'm just asking for a friend.
Foreshortening?
Yes, please.
Oh, it's just
For,
like
for the audience.
Bendy's space showed at 56 past the hour.
Well, I'm looking for a definition.
Of foreshortening? Oh, welcome to your local Merriam-Webster representative. Hold on, let me research that for you.
okay, while you're doing that, didn't Soundly say that's the actual curve and we measured it?
Yes. That's what they said, SE.
Just checking. Yeah.
So, yeah, I just kind of wanted to ruin the argument for Globers that they say Lake Pontchartrain shows curvature. No, it doesn't.
Well,
Nice
it
job,
does.
Fiesticles. You killed
No,
them.
thank Taylor. Thank Taylor. Taylor's the one that put all the hard work in. Took her like 2 weeks to get the as-built plans because she had to go through the government, like the state, and then they pointed her to like this commission that they use, this third-party commission, and they pointed her to a different thing. Finally,
Yeah, it's not hard. All you have to do is go to a building department and FOIL a request. It's not hard to get as-built plans.
well, it wasn't a government project. It was actually a third party, so she had to go through this
It doesn't have
commission.
to be a government project.
Well, whatever.
I would think you would at least need to be
can
like
get
a
that.
homeowner, though, or like a landowner to request that
Nope.
kind of information, no?
Nope, freedom of information.
So you
FOIL.
could just have some European dude come on vacation and get that information, go home and build bombs to blow it up?
Yeah.
Well, he wouldn't need that information to find the location of it.
But you guys are saying that there's no Earth or around Earth mentioned in the building plans. That's the proof.
There's no curvature mentioned whatsoever. There should be a
Well,
360 foot.
I still don't
status
understand
on-
why that should be.
only if you determine that sea level isn't curved.
Right. The plan says it follows sea level, whatever
So-
that is.
Yeah. So there's no need for it to say that there's a curvature, right? Why would that need to be?
For 24 miles?
Yeah, hold on real quick. I just want to read the definition of foreshortening, because we didn't get Jesse to read it. Foreshortening refers to the technique of depicting an object or human body in a picture so as to produce an illusion of projection or extension in space. How is this soundly thing foreshortening, dude? What are you talking about?
Because he's viewing it from the end, like sighting down a 2x4. You know, have you ever been to the hardware store and you're sighting down a 2x4 to see if it's straight before you buy it? Yes or no?
Or
Yes, continue.
that's
Okay.
rhetorical, bro. Obviously, come on, man. What the heck are you doing right now? Are you
It's not
saying looking down a 2x4 is foreshortening by definition? Because foreshortening has to do with artists. You guys do this with perspective as well. This is a technique in the art field of depicting an object or human body in a picture so as to illusion of projection or extension in space. So
Huh.
I understand what you're trying to portray here, but I think you need better words.
Are you saying it cannot be used in photography?
No, you guys are exhausting, dude.
I
Just
Well,
straight,
yeah, no, because
straight
like if
war of
you're acting like
attrition with you guys.
there could be like two definitions that you're talking about. Like artist renditions is one thing, but he's talking about photography. So why don't you look up like what's we call it, the aspect ratio thing for photography? It's
Reduce, shorten. That sound like what you're trying to get across here?
what I'm trying to get across is if you don't like the word, scrap the word, but I illustrated it perfectly with
Yeah,
the
yeah. You know
2x4.
what?
Hold
I
on,
think that
hold
you
on.
have.
I'm
I don't. I
almost
don't think
done
you have the
here. Just
credentials
let me
to
finish.
speak the English language. Do you have an English college degree? Are you a doctorate in English? Because then, if you don't have the credentials, I don't want to hear it.
You're
oh,
just
so
playing.
everyone in high school doesn't know the English language apparently.
Yeah, exactly. Apparently, that's the kind of proofs you guys use. I don't know if you notice this, but this is
No,
what
it's
I
not.
do. I hold mirrors up to you guys, and
No,
then you
you
go,
don't.
"You're ridiculous." I'm like, "Exactly, bro."
You're just using word games to get out of the topic, which is if you sight down a 2x4, you know that if you can sight down it, and if it's even slightly curved, you'll see that curve. But if it's perfectly straight, it will look perfectly straight when you sight down it. And that's what they did with the bridge. Sighting down something does not create curve if there's no curve. It just lets you see curve that's present, right?
So things can be perfectly straight?
If you've ever set trusses on a floor, like floor joists, you do a thing called crowning. You look up each one, and you put the crown to the top on every joist. Everybody does it. Every contractor does this that builds a house.
Wait, Jesse.
Is
So if
there
it
is
looks
there a way
perfectly straight, then
hang
it
on,
is straight.
is there a way to view
I
that
didn't say that.
warp is there a way to view that warp 2x4 in Home Depot as straight? Is there a way that you can view it where it looks straight?
Yeah, put it on the floor.
Flatten it.
No, not actually flatten it, but like
Eh,
from a certain point of view, that
So
curved 2x4 can look flat and straight.
if
That's his point.
everything is
yes,
pulling
When you
toward,
look
if
at it,
everything's
when you
pulling
look at
towards
it
the center of
down,
Earth, how's that possible? How are you getting anything straight? If everything is pulling towards the center of the Earth, how is it possible to have a straight 2x4?
How would
so
you
you don't
measure
have
its
the ability
flatness?
to engage in the conversation.
How would you measure its
that would be
flatness to
good.
confirm that you
Wait,
flattened it?
Wait, are
did
you?
we wait 1 second, Tora. They just skated past what Jesse just said. All right, he just admitted that if something looks straight, it is. No refraction. So if we say something looks straight, then it is, right? He just said that.
Well, yeah.
Well, I said the 2x4. If it looks straight when you're sighting down it, then it is. That's what I said.
So if
But
something
then,
looks straight, appears to be straight, then it is.
what
Only if
defines
only if it
straight?
appears straight from every single aspect ratio.
Yeah, it depends on it depends on how far you zoom in, right?
You got to get a perpendicular perspective.
Yo, nice, fresh grown. I caught that. Nice, bro.
Yeah, you could look at a floor joist side on, and you can't discern that it's curved or not curved or which way it's curving. You have to look at it from the end.
What's the point?
Point is,
Well,
there's
his
no
question was:
argument.
is there any way you
Yep.
can see a curve and not see the curve? Yes, there is a way. You look at it side on, and you can't see the curve.
Okay, so does a spherical object have this same thing that something linear extending out into space has? Same problem?
I'm talking about a floor joist.
Oh, okay. I thought so. You don't have a point. You're just like talking about flooring right now for some reason. What's the topic? What's the topic?
Maybe you're not listening. I don't know.
So there's no point to your statement except that you think you could lay some good flooring because you got some eyes.
Don't trust your eyes, though, Tora.
But
You
our
guys just
definition
question
go
was-
back and forth, double speak all the time,
you have
bro.
to
It's
cross
crazy.
everything
Go ahead,
that
Essie.
you can see.
Well, on the bridge, is it an actual curve that Soundly took, or is it not an actual curve? I think that's what we were on.
Well, if refraction is capable of reaching claimed Earth curve rates, then I guess you could say there was some unlikely condition that caused it to appear that way. Some top heavy density gradient that caused it to appear to curve down. But if we're all going to accept that refraction can be that strong, then that also explains how the black swan could be possible on a globe.
On what size globe?
A 3959 radius globe.
Okay, how much refraction is required to have the black swan observation?
0.13 degrees centigrade of temperature rise per vertical meter.
Well, let's think
What
about
are
it
the
in
two
like
media?
what
are
you
the
know what
two? You gotta
normal
look through
refraction.
two media.
Yeah,
You gotta
no,
look
I got
through
it
two
there.
media.
There, hold on. Normal refraction would be a lot of people will say like standard refraction 7 inches per mile squared. What is like use something like that just so I understand. So instead of 7 inches per mile square, what do you think it would be at that degrees you just gave?
8 inches per mile squared.
Oh, so the black swan depicts 8 inches per mile square, and when we include refraction.
I'm not sure what you're asking. It would take.
Yeah, what I'm
only-
asking for is
Just
you
let me
claim
finish.
the amount of refraction that was there. And I'm saying, well, a lot of times when we get standard refraction, they'll tell us that's like 7 inches per mile squared. So now I'm just asking you to relate the amount of refraction that's at the black swan to a similar statement, like was it 6.5 inches per mile squared, 5 inches per mile squared, 10 inches per mile squared, something like that.
You done?
Refraction doesn't give you 8 inches.
He doesn't have it because it's just an assumption. That's why he said if you assume that it maintains that particular index for every meter from the observer to the observation point, that's an assumption. There's no way for them to confirm that.
Yep, unfalsifiable.
I just want to answer from
Yeah.
Jesse because he could do the math here and tell us how many inches per mile squared is required in order to have a black swan measurement.
A total net.
Well, I mean, I would not speaking for JC, but if you had the right refraction
How about you don't speak for
conditions,
Jesse
you
then?
could see 0 inches per mile squared.
Okay.
He might
So
agree with me.
there's an opportunity on the globe to have 0 inches per mile squared due to refraction on your curved surface. Correct? Jesse, do you agree with that?
Why don't you let me answer the question you asked earlier? It would take a total refraction of 8 inches per mile squared to equal Earth's 8 inches per mile squared globe. Anything at or above that amount would give black swan results, and I have documented cases in my own black swan results where the horizon and objects at the horizon were actually above eye level, which is also impossible on a flat Earth if light can only go straight. So we know that refraction can cause things to lift up and make
Okay.
the Earth appear flat or even concave. So if you're going to cherry pick from the
Yep.
surface,
Or
then you cannot
down.
make flat Earth arguments.
Yep. So what he just claimed, ladies and gentlemen, I would like to declare for the audience, please. Jesse is claiming the first question I just asked. And he said I want to ask the previous question. He did answer. He said the 8 inches per mile squared can be canceled out because light can curve at 8 inches per mile squared. So what they were saying is that the surface of Earth would actually look like it's not curving at all per mile squared. So 0 inches per mile squared. That is their claim at this point. that
At
it
the
looks
surface,
exact.
only
Yep,
at the surface. Don't misquote me, okay?
yep. At the surface, it can look as if it's perfectly flat to the
Or
point that it looks 0 inches per mile squared, no obstruction. Even though, ladies and gentlemen, in the Black Swan, there seems to be an edge to the horizon.
If
He
that's
doesn't even
if
know what he's
that's the
talking about.
if that's the case, then I'm just going to use the same trick that I did in Home Depot when I looked at the board and assumed that the straightness equals that it's straight and flat.
a 7 mile long board.
Well, I mean, what's the difference if my eyes are seeing that it's straight? Why would it change on a larger scale?
Yeah, all your 2x4s, for all you know, could be curving at a rate of 8 inches per mile squared, and that would be perfectly fine and level and straight for you.
It's because the rate of refraction of the light you're doing in the small scale is not matching the curvature you're seeing in a large scale. So what is it? You guys have all these questions for the Globers. What does this do to help your case?
Hey, can you define the Socratic method for me?
Tora, you've got all these questions for Jesse. What did these questions ultimately lead to?
They show the absurdity in his point of view.
It's not absurdity. It's consistent. There's a system. It's testable. It's repeatable with
It's
numbers, math,
definitely
and
not that.
measurements to boot.
Yep, except when you use logic and reason and rationale, it doesn't.
Ladies and gentlemen, pay attention to how he just completely ignored the evidence, the system, the math, the testable, the repeatable, and the numbers. Does FE have any of that?
Yep, horizontal measure.
The assumed unverifiable numbers?
Yeah, horizontal measures level every single time, bro.
Pretty simple, actually.
Well, what about this though? How can horizontal be level when I'm looking up at the horizon 2.6 miles away?
Because
Up at the water.
you're not measuring if horizontal is level. Obviously, you don't even have a spear level in that picture. You have nothing. You have no tape measure. You have no tools to actually measure horizontal being level in a practical sense if you're going to build something.
No, this instrument has a spirit
Look
level,
at
and the angle reads out in the VA line. So you can see I've got the crosshairs levels within an arc second.
Okay, what does that matter though? I'm talking about over 10 feet. Everyone here agrees that horizontal measures level, right?
Well, and we also agree that over 10 feet, uh, the level measures indistinguishable from a 3959 radius curve. So,
Yeah, so until someone measures 3959 mile radius, we'll just go with my premise since Occam's razor.
and so let's say we develop a way to measure the curve over 10 feet, then you're going to say, well, okay, you got to do it over 1 foot. Is that really honest?
Yeah, if it's scalable.
The point is, however small of a distance we can measure it in, you're just going to pick a smaller distance.
It's not the case. You don't know that to be the case.
I do.
But you're not measuring anything, you're assuming it.
Well, let's see. Now that we've set the standard,
My
then,
worldview is consistent, dude, and I'm not changing. I'm not being inconsistent here. I think that every 90-degree angle is 90 degrees, bro. So every time you drop a plumb bob from the horizontal, that's perpendicular to the horizontal. So if I measure it everywhere I measure it, it's 90 degrees. And I know that you claim the ball would do that, but I could spread these apart and then measure the distance from the tops and the bottoms.
do
Really?
it.
What experiment is that? I'd love to
And
see
get
that.
Do it. That's all I can
I'd
say.
love to see that.
yeah. You want
can't-
me to pull out a spirit level right now and some sinkers and some string?
That's what you said you'll do. So we'd love to see it. Also, you have to do it in a larger scale. For example, not like separated by 10 feet. But yeah.
Well, the spirit level I have is only 6 feet, so I was going to do it on a smaller scale. Why? Is something like that not going to scale up? Is that
Let
what
me
you're
ask
saying?
you this. In your small scale, what do you think the deviation from the plumb line is going to be? Whether it's converging or diverging, what do you think it will be, and how would you measure it?
On the 10 feet, on the
How would
10
you
feet,
measure
I
it?
don't know. I think it's like on a half a mile, it's like 2 inches. I think on the 10
2
feet, it's
inches. Heard that, Jesse?
0.002
2
inches. Right?
inches of
0.002, I think,
deviation.
on the 10
How
feet.
how far away are your plumb bobs separated for you to get these 2 inches of divergence?
Oh, I think that's a half a mile.
Okay, love to see it.
No, I was saying, but so for 10 feet, I think it's like 0.002, right?
How are you gonna measure that?
With a tool that measures thousandths of an inch.
Do it. You can't appeal to a measurement that you haven't made yet or that hasn't been done yet, okay? It's like I could say, well, you know what? I can tell you, I know that if I did this, I would measure a divergence of the plumb bobs, so therefore let's agree that I did it and that's what I measured. If I haven't done it, I haven't done it. I haven't got anything to appeal to, right?
Can
So I
you
just
apply that for
understand
your
how a
lack of
building is
measurements that
built.
you've made?
You know how foundation is built? Do you think that they're all just 10 feet across or what? Foundations are built level, so that way when they put walls up on them, they have 90-degree angles between the wall and the floor. Did you know that?
Yeah, but
And the relevance of that is what?
Those walls are parallel, and they use plumb to get them that way.
Oh, okay.
So you don't have diverging plumb bobs then. So you're done.
well, it wouldn't really
Nice
matter.
experiment.
It wouldn't matter on a building when we're talking about a few 10,000ths of an inch of difference. They don't even cut the building materials to that accuracy. Right? Am I right?
Yeah, that sounds correct. So they're not 90-degree angles,
Well, Jesse, wait, did he say
right?
he wanted diverging plumb bobs? I got them. Posted them in the chat.
I've seen converging plumb bobs literally with plumb bobs down those huge mine shafts. Shout out Joe Dubs. Bro,
Well,
like, so we have converging and diverging, and I'm claiming at 10 feet parallel. So what is conclusive about this information?
Is that neither of those are flat because converging is not flat and diverging is not flat. So that's what I can conclude. What do you
And
think about that?
parallel. I said and parallel. Did you miss that one?
I
yeah,
I
but
I missed the
what?
part 5 minutes ago where you claimed boldly with your chest out you'll do an experiment, and now conveniently you're laying it on someone else.
And also, you can have converging plumb bobs if like if you have a geographical feature like a mountain that affects the plumb bob itself.
So what's the best way if you're building next to a mountain to get plumb?
What's you account for it? What do you mean?
What's
Did
the
you
best
remove?
way? Like you're saying, because a plumb bob obviously is not a good choice because the mountain's going to affect it. So what would you do to make a 90?
I mean, how much is it affecting it? That's the thing.
I don't know. You said it was affecting it.
Yeah, it affects the plumb lines, but to like what level? Like to what? Like I mean, if you're talking about like a second of a degree, it's kind of irrelevant when you're talking about a building that doesn't stretch like that long of a distance.
And if I were building a radio tower and it's near a mountain and the
You probably
hanging of the
wouldn't want
plumb bob and that hold on and the hanging of the plumb bob is showing normal to the gravity vector, I'm going to build that radio tower parallel to that plumb bob.
There you go. Yeah.
And the difference between the hanging of a plumb bob across the valley will be maybe a few arc seconds different, but
Well,
across the
yeah,
valley,
you're
uh,
right. Technically, right? They wouldn't. Plumb bobs aren't even really pointing towards the center of the Earth because the Earth is spinning. So that means they're all kind of drifted a little bit from the center.
they're normal. They are the net vector of gravity. Yeah. So
Yeah,
when
it's
you're
the
going
net
to build
vector.
something that's plumb, the hanging of the plumb bob is a good definition
What
of
about the
plumb
precession?
at that location, and a radio tower would be in concentric with that plumb bob. Yeah, because that way it would.
What if you set up your plumb and then come back in an hour and then read it after the 15 degree deviation and you're thrown off?
It's not because it's all rotating together, so it wouldn't be. Um, But a good historical fact, like just an anecdote, is that when they did the Ohio-Pennsylvania state borderline, they noticed the effect that these mountains were having on the plumb lines through reciprocal zenith angle tests. And one of the understudies of that surveyor was Cavendish, and he realized this, and that's like what led to the Cavendish experiment. Fun little fact.
Yeah, and that's the difference between geoid and ellipsoid.
Yeah, the geoid uses the gravity.
Yes, but yeah, as I posted, in response earlier, the definition of elevation is against the geoid, and geodetic is against the ellipsoid. So yeah, there is that slight difference, which is why when observing stars, you get astronomic coordinates, which are projection of the geoid, and then if you want geodetic coordinates, you have to account for that difference between the equipotential surface of gravity and the mathematical surface of ellipsoid. Yeah, this is very high science. It's been investigated for a couple of centuries.
Yeah, I posted in the chat. I have my surveying FS Fundamentals of Surveying Exam Study Manual, and I showed it. I posted that in the chat.
Well, is it science or is it pseudoscience? Because there's a difference.
It's science because it leads to predictable and accurate results.
And I get repeatable measurements. And my measurements comport with my 100-year-old textbook.
Yeah, but your measurements is biased based on the globe, right?
No, my measurements are based on an objective instrument.
Your observations.
Yeah, when we say observation, okay, in technical terms, an observation is a measurement.
Yeah, using the globe radius, right?
As previously measured, repeatably, yeah.
Right, exactly. So you're using the globe radius.
That's been measured, which has been measured repeatedly, yeah.
And when we do that, we get accurate results. It's amazing.
If you're in question about the radius, you could do measurements to determine the radius prior to, and then it's not an assumption.
No, but the difference is you're pre-assuming it's a globe to get that radius.
No, you can't just say that, because when I made the measurements, I compared my results to what I was told, and I was only different by about 25 parts per million.
Exactly what he just said.
Yeah, when I did the reciprocal zenith angle, I was like 85% accurate, but that was over 1,500 feet. I mean, it's
Yeah, no, and the example I bring forward, I'm at 11 miles, 52,000 feet, 55,000 feet. Yeah, and I get 7 arc minutes of deflection between the two plumb lines at each instrument, measured repeatably.
I got about 8 seconds of a degree between
That's just
1,500
refraction.
No, it's not.
Yeah, sure it is, dude. Prove it's not.
It's not.
Refraction is a small part of it, because yes, I only got like 7.5 minutes instead of the 9 minutes.
Oh, so it could be inaccurate then, right? According to that.
Not could be, was just claimed inaccuracy. Did not get the result.
Are you talking from your own field experience in professional
we're going based on what
practice?
you're saying.
No,
you're
we're
off
going
2
off
seconds,
of yours.
right? You're saying your number is 2 seconds off than what is reported, right? So therefore, you can't just say, "Oh, it's close enough." The sun is 93 million miles, but at one point it was only 5 million. We're close enough, right?
So now we're getting back. Now we're getting back to accurate versus precise. His measurements are accurate; they're just not precise.
No, they're not accurate, because the lack of accuracy is what the claimed curvature is.
Okay, GNS provided this to Shoebill. The first reported distance from the globe to the sun, it was 3 million miles away. Then it went to 8, then it went to 15, 20, 50, 80, and then it's 93 million miles away.
Yeah, since about 1639, it's been like 90 million miles away. Now, if you want to quote the 3 million miles away, that's pre-technology. That is like, 100 years BC. Yes, without technology, they still didn't get 3,000 miles like a flat earther might say.
Okay, so you're saying 93 million miles away, so who's to say in 100 years or 200 years someone's not going to come and say, "Oh, it's actually 100 million miles away"?
I mean, that is science, just constantly being wrong.
Actually, there's a very good chance that will happen because it's been changed how many times? 10 times or something? I have a chart. You guys
No,
seen
it's
it,
been
Yeah,
right?
but,
no the value has been refined by measurement.
By like 90 million miles.
No,
yeah,
what he's saying is,
if you're
Technology makes a better
refining and you're
measurement.
getting better,
Technology makes a better
yeah,
measurement.
if
As the
you
technology improved, the
yeah,
accuracy of that measurement improved.
yeah. So what he's basically saying is, when you're disputing these numbers, how it has changed over time, he's not denying that. But what he's saying is, because back then there was no technology, and now they have so much technology, it's not going to change again. But you're wrong, bud.
it's going to converge on the actual number, though.
It's not going to be revised much, if at all.
The distance to the sun is just a hypothesis. You understand this, right? Just because
No,
you set your radio there, 60 minutes later it
It's
sends
not
a
true.
signal, that doesn't mean you could physically measure it. Like, how can
I
you
mean,
physically measure it? Can you hold a tape measure from the ground to the sun? No.
no, it's called radio
yeah.
measuring. Like you use radio.
Apparently, if it's not, apparently the all construction of all types must use tape measures instead of lasers or microwave radio.
No, but the difference is, see, now you're doing it again. The difference is with those measurements that you're referring to that doesn't use a tape measure, you could verify it with a tape measure if you wanted to, because they're on Earth, right? It's
Yeah.
different.
So I verify the laser measurement against the tape measure. Then I go and make another measurement with the laser, and I don't use the tape measure. Is that okay with you? I calibrate the laser against a tape measure, and then I use that laser throughout the entire construction site without ever using the tape measure again. Is that okay
Yeah, but
with you?
we're not talking about the construction site. We're talking about the distance to the sun.
Yeah, and he's saying that if we use the technology like radio wave technology to measure distances, and then we realize that it matches up with the actual distances, we can then use those radio distance measurements to determine things that we can't measure with the tape measure, and that's how we get the sun's measurement. There you go.
Yeah,
There you go.
theoretically, that's correct. But the problem is with the sun. That's why you can't use like a real life example of construction site, because you can verify that it's on Earth and you can verify with a tape measure. The difference with the sun, there's only one method, which is literally the radio signal sending the signal. 60 minutes later, it comes back. Any other hypothesis is based on a math formula or something that's not physically observable.
And the potential weakness of that radio thing, hypothetically, there's other variables involved in the measurement. Speed of light is an assumption, is that it travels the same rate. Another assumption is that light travels straight. Those are also two big factors that are assumed in the way we do things. If those hypothetically were wrong, then that even that radio thing wouldn't be correct.
Yeah, lasers. And it also doesn't. This just came to me like when you send a pulse out or anything else other than what we know about radar or how we think light works. The largest amount of energy is when it first comes out of the tool or whatever you're using, and then it seems like it would slow down just naturally, especially when it's reflected off something. But when it's also going through different mediums or different densities, it seems like it would slow down if it's just energy. I'm not sure if we have light figured out as good as we think we do.
See the difference. Okay, this is where the problem comes in. Okay, you could say, okay, we think based on the calculations we've done, based on the laser signal, we estimate it to be 93 million miles away, right? I promise you, most flat earthers will say, okay, that's your estimation. That's what you think. No problem. We'll take it, right? The problem with the globe is you're coming out saying it's 93 million miles away, not an inch of doubt. It can be this, even 1% wrong. This is bullshit. There's no way you could claim this.
Yeah, they're
Nobody says
also
that.
telling us, well, yes, y'all do. Your scientists say that. Because if it is wrong, the distance is wrong, then everything else is wrong. That's the problem. That's why they had to change the distance in the first place. It's not because they had better tools. Well, that might be one part of it, but because things wouldn't work out. If it's 5 million miles away, everything else doesn't work out.
Yeah, if it's 5 million miles away, yeah, our whole life is fucking different, and it's not 5 million miles away.
Yeah,
Well,
but we're
that's
not.
our whole point, though. When it's 100 million miles away, 10 years from now, or 20 years, or 100 years from now, then what? How does that change our life? Like it has to change everything. Sizes of things, distances to other objects, right? You agree with that?
So how far away do you say it is, and how did you measure
It
it?
doesn't matter what I say. I don't think I've ever said how far. I don't think
Well,
it's
why are you
possible to
arguing
know.
about it then? I mean,
What do you mean?
what's your
I'm
argument?
not arguing with anybody. I'm just stating a point, like adding to the conversation. Unlike left lane again, you're such a dick, bro. Can you add to the
Well, hold on,
conversation?
hold on.
Here we go.
Yeah, well, I'm not going to allow you to attack people every time they come
No,
in,
left lane's
especially
fine,
me,
man.
and not attack you back. Like,
Okay,
come
one
on,
I
second.
man.
just asked a question, Rakia. I just asked a question. Is all I did.
Yeah, you just
Okay.
asked a question about me. You didn't
Hey,
ask
No,
a
left
what?
lane's
question about
fine,
how
man.
far
Whoa,
the
you
sun was.
guys. What's going on?
Yes.
Sorry, I apologize. I missed all that. All I heard is that Rakia, you were calling somebody a name.
Yeah, I
Can we
did.
not? I don't know if he was triggering you, but we still need to refrain from that. And I'm sorry, I wasn't hearing all that. But can we just try
Yeah,
to reset
Yeah,
a
let's
bit?
attack the argument, not the person. But the problem
please.
is the globe Earth, the first defense mechanism is, oh, okay, so you're saying it's not 93 million miles away? Okay, what is it then? That's your first defensive mechanism. It's like, no, the flat Earth, I'm not even a flat earther, by the way. The flat Earth community doesn't make claim what the distance is. Even back 10 years ago, when there was this theory of 3 to 5,000 miles away, they said we estimate that's what we think it is. They never said this is the exact numbers.
Well, I think they get that. I think they get that from an angle measurement, right? Like if you
Would it
take
make
an
you
angle
feel better?
measurement somehow.
Would it make you feel better if we
Nobody
estimate the
says
sun?
you can't measure it. You can only
Would that feel better?
calculate it. You guys, you can't get to it, so you can't.
Robot. So would it just make you feel better if we said we estimate the sun to be 93 million miles away? Would that make you feel better?
Well, I
It'd
think
be a
it's
little
still
bit more
troublesome.
intellectually
No,
honest.
because you can't. Okay, demonstrate how is it that you think it's 93 million miles away?
Through radio.
That's the only thing you
radio
got, a
wave.
radio signal
Well, there's
and a mathematical formula, as Shoebill loves it.
radio signal is like a virtual way of drawing a ruler to it as best as you can. You do it in the form of light. They assume that light travels a certain distance in a certain time. So when they shoot the beam and it comes back, that time they're plugging it in and working with the assumptions with how light speed travels. And in the Glober model, it's working out for them. Now
Not really, because
we could sit here and keep casting doubt, but casting doubt can always be casted no matter what.
well, I wouldn't say it's working out for them, because if they would have told you it's 100 or 80 million, it would have made a difference, right?
It does work out for them because the sun has flares that come off from the sun, and they're able to accurately predict when those flares will reach the Earth and sometimes impact our electronics and our stuff. So they do have a predictable way of doing that.
I think the moons of Jupiter were also used to measure the distance to the sun.
Now, they have a predictable way of measuring that. The only way that could be wrong is if the variables are flipped around that are baked into the assumptions. So the assumptions is that light travels straight. The assumptions is that light speed from here to the sun and back remains fixed for the most part. So if those in the future are determined to be wrong and say light slows down big time from here to the sun, then those distances are gonna change. So
or speeds up.
Right. Now there's no other way that a man can give you the confidence in the global model. They have this system All the numbers check out in the system. They're able to make predictions. They say the sun's 93 million miles away. It may not be, but when they say, hey, on Saturday, our communication system are going to get fucked, they're right on that part. So I don't know.
They have a huge amount of confidence in the fact that they know they're wrong. And in the future, the technology will come about because they're so smart to develop this to prove themselves wrong.
That's where the 99.999 comes in, Rakia. They leave themselves that get out
Yeah,
of
it's freaking
jail
clever,
card.
right? Like it's the most clever thing I've ever heard of, where you can develop a scientific, theological makeup that you can teach the world that you're never right. But answer it on the test this way right now so you can become smart like me, and then when we're proven wrong, you'll get a prize for it. That's the most ridiculous thing I've ever heard of.
Well, what's your position? Are you a flat earther or glober or concave earther or what?
I'm definitely lean towards the flat earth. I'm more of a biblical earther. I've measured a section of earth of static water that I can't measure the curve of. But how can I tell you it's flat when I haven't measured it myself? Like, logically, I think it's flat. Anytime I study how water works or how containment works, or I study my religion, the book that I go by, which is the Bible, it definitely tells us that we're contained, we're stationary, and that all concludes to what y'all call a flat earth. But I'm on land right now that's not flat, right? It has a slope rise over run based on horizontal that lets the water flow. That's how I know water to flow. I mean, every piece of water I've ever measured is not curving. Every piece of land that I've ever measured has rise over run to its slope. And the water seems to be at a lower level than the land around it, which is containment. I don't know how that's so difficult to understand when I'm told by all these smart guys that have measured by centimeter accuracy the distances to stuff and the elevation from thousands of miles away to the tops of the mountains, or hundreds of miles away using a piece of mirror or glass through an atmosphere, that they tell me how accurate they are, but yet can't make a horizontal line a mile long. That dog don't hunt in my book. Now, it might add up to you, but not to me, bud.
So I don't get how other people don't have accurate instruments, but you somehow have these accurate instruments.
Yeah, I agree with you too. I don't understand how you and every other globe I've ever talked to can confidently say that we've measured every inch to the moon, centimeter accuracy of wobbles, elevations from thousands of miles from mean sea level, that we've gotten that particular level over years and years, but you can tell me exactly to the inch how tall a mountain is, but the same people can't make a horizontal over static water a mile long.
Yeah,
we don't have the tools accurate enough to do that.
As a surveyor, can you explain that, Shoebill? How did you take a measurement like 100 feet and claim this is the Earth's measurement when you haven't measured the whole fucking Earth?
I mean, that goes back to what I said before, is where we get these geoids is based off of a datum, and the datum is a series of data. It's not just off of one small section.
I think, Shoebill, if I may, you've said that the datum that we get from mean sea level is planar surveying over a curved surface. Like, we take shot after shot of horizontal lines getting elevation change, but the overall, elevation is over a curved surface. Like I say, in Louisiana, I'm 66 feet above mean sea level. But what you're saying, over that 100 miles from me to the point where they take mean sea level, it would be 66 feet plus whatever that 100-mile is on the radius, the drop. It doesn't add up, man. It just doesn't make sense to me. But you say that's how it's done, right? How many horizontal lines does it take to make a sphere?
You could have it in
Or
the sphere.
or it's just a plane, right? It's just a planar, you know, that we live on. So
There's consequences to planar.
Well, in
There's
Florida, in Florida, elevations are a very, very serious subject. So when I did a project for the Southwest Florida Water Management District, I was quite impressed with the dissertation they had on elevations. This is a very long time ago, so and this, it's not like an internet document because I was working on a project, and they take their shit very, very seriously, which is why when running differential levels, the main reason you keep the instruments to like 60 or 70 meters and have to be absolutely centered between the two leveling staffs is because of curvature. So yeah, you're dealing with these 150 meter segments, and you leapfrog along, and you go from the ocean to your house, which will take thousands of measurements very carefully with very expensive instruments, very complicated procedure to avoid errors, because in Florida you can't surrender an inch. In some counties only have a couple of feet, from end to end. So when you're dealing with an all wet system, yeah, elevations by definition against a measure against the geoid, as I posted. So yeah, and planar surveying doesn't address elevations.
So you're telling us that they're really technical about elevation because of how curved Florida is? Is that why they say it's the flattest state in the U.S.? Is that why they say that?
I say that because there's not much elevation change across a given area, so water flowing and flooding and sewer systems are of supreme importance, because they can't have inch errors,
curvature
cropping up all over the place, because they don't have that many to deal with. You get into some hilly areas, where they have hundreds of feet of elevation change across a municipality. A foot error in an elevation that's halfway up a mountain doesn't matter.
you're saying
So
over
Shubo,
Florida.
I'm sorry, Shubo, real quick. I did post a video about Florida derived heights and everything. If you wanted an actual YouTube video about how heights are derived in Florida.
Well, he knows. I mean, he knows from his books and stuff, and I get what he's saying. But what you're telling the audience and me is that they can accurately measure over a state or over line to line or a large distance inches of elevation change, but can't measure the hundred, like a mile of drop due to curvature. It's a strange thing, man.
Rakia, would you mind taking like the hour or so to watch the video I just posted? If you're very interested in how these heights are derived.
Yeah, absolutely. I'll watch another video on it.
Okay, cool.
I mean, you have to understand, we have to study this. We take tests on it to pass our contractor's license. We deal with surveyors. I paid one yesterday. This is conversations I've had with surveyors, not only Shoebill, and I understand where they're coming from. Most of these surveyors that I talk to are Globers, but they're more understanding the fact that they've never really actually measured curved water. Right? They've just applied the knowledge.
I'm really confused on this, because it's like, if it's such a big importance for this elevation to not deviate, because the water's gonna not stick to the curvature? Like, it's not what's going on with the water, Bill? Why?
Oh, that's a different topic, but water would have to curve.
It's a different, it's not involved in this.
Well, it would have to curve on a sphere, and it would be horizontal on a plane when static, and that's what we're saying.
So if the claim is that water is sticking and adhering to the curvature, then why would curvature be such a big drastic thing?
Well, if it is sticking to the ball, and it is curving, and you can accurately measure elevation change from a benchmark to show over Florida that it's 2 inches difference over hundreds of miles or whatever you want to say, then you would easily be able to establish a horizontal from a benchmark over static water and show that curve. You can't. That's when they have to say, including Shoebill, when asked directly, that the tools aren't accurate enough to do that.
No, okay.
And the other,
There has to be two things to make this horizontal a mile long to show you. There has to be two things. There has to be a need and there has to be funding. And we don't have the need, and nobody's
That's
going to
ridiculous.
cough up the funding. And then once that's done, how are you going to make any verifications? You're going to get your levels
There you
out
go.
and then make a progression series of measurements. Yeah, okay, yeah, it's all good. The
So
problem,
you're coming up with more excuses.
just like the Lego tubes, are exactly what people keep
Oh
asking
boy.
about, and it's exactly built, to like the force the line, but they don't like the authorship. So you're going to have to do it yourself because
well,
if
they
I did
already
it, you don't
started
like it.
building it in Saudi
That's
Arabia and called it the
why
line.
surveyors actually once a year will go to known benchmarks and do static elevations for, like, the requirement is basically 4 hours, and then you submit that data to see if there's any changes in that benchmark, and that's how they update the datums. Just so
okay,
you know,
there's a
for
few
your
points I want to
information.
make out here. There's a few points. First of all, can we unmute this guy? He wants to really jump in here, White Rabbits. But the point is, the thing with Shoebill, there's two things, okay, where this guy pointed it out. One is that he's already telling us he's pre-using the radius on the globe side. So he's already, it's not a neutral ground where he's starting from zero. He's already pre-assuming the radius. The other problem is he worked for a third party who was supported by the Globers and NASA and all these guys. So there's definitely a bias in what he's done, even as a surveyor.
He's only pre-assuming it as much as that's what's necessary in order to do the math. I mean, you have to do something. You're gonna pre-assume it's flat. You're gonna pre-assume it's concave. You're gonna pre-assume it's globe.
Well, that's not unbiased then, right? If you're going
And
to use globe numbers.
well, I made measurements over 520 miles to the point in the middle, and yeah, I got a radius.
So how you said it's unbiased? I mean, one has to choose a bias when you're doing the math. You could do the math for all of them. The Globers have a model where there is the math for everything, and the other side, where is it? The Globers have their system, okay? They've got their pre-assumptions, they've got their assumed distances, they've got this thing that they're calling and claiming is reality. And what it seems to be is they could use the details of this thing and it's works out in real life. This model gives them distances, and in real life they could use it and get to places on time.
Why do
This
you always come in
model,
here and
this
just jack off
model,
the
get
globe, but you
this
never contribute
model,
to the argument?
this
You
model
just
gives
try
them
to
angles.
gaslight
Look,
flat earthers. That's all you do.
listen to the guy speaking. This model gives them angles and predictions, and sun comes up here, we hear it here at this angle, and it seems to work out for them. So and they also have a model when it comes to curvature. We're on top of a mountain and we see what we see. They've developed a system with assumptions baked in that it gives you a testable and repeatable thing, where it's someone like Jesse can go on a mountain, use his tool, work within the Glober guidelines, and it gives real results. And the only issue that this community has is, oh well,
Are
where's the
you done?
curvature? Oh well, where's the curvature?
Are you done cheerleading for the globe, or are you going to
Well, I'm
argue
gonna
any
go on
type
mute,
of
and
point into the
we're gonna hear a
conversation?
real intelligent response to what I just said.
You're just jacking off the globe in here. That's all you're doing. You're not actually you're not interacting with the conversation and haven't been at all. You just interject and try to cheerlead for them. It's really weird.
What's one false thing he said?
Well, of course, he's your cheerleader. You're going to stand up for him.
I'm not standing up for him. I'm asking you, what's one false thing he said?
The only thing that I would disagree, you could go stand on a mountain with a theodolite, no assumptions whatsoever, and take an angle to a mountain of known elevation at distance and see what you get. See which model fits it best.
Yeah, it fits the globe model.
Well, we have to understand that, first of all, 99% of the population is a write off because This is what you learn in school. No one really challenges it unless they get onto these discords or watch YouTube videos, right? So the average population doesn't debate flat versus globe Earth. They just accepted that it's a globe. They trust NASA. What? What?
Nobody said anything. What are you whatting about?
Yeah, someone interrupted me. It was a lady. I don't remember what she said. Anyways, back to the point. So the globe, they already have the narrative that majority of the people are gonna just pre-assume it's a globe based on school.
Not just school. I mean, you can just use basic logic also. Like, as I'm coming up to a hill, things past the hill start to appear top up. And as I get to the top of the hill, I can see more of the bottom of them. As things go further away from my point of view on
Yeah.
Earth, I can only see the top of them. I can't see the bottom of them anymore because Earth is one big hill. I mean, there you go.
If you're at the top of the hill, can you see the top of the hill?
Yeah, you just look down.
Oh, you look down. Okay. So you wouldn't look. You don't look up. You're looking down.
To see the top of the hill when you're on the top of the hill. Yeah, you look
Yeah.
down.
Yeah,
but what
because you
about
guys claim that you're on the
refraction?
ball, and if you're on the ball, you're on the apex. You're always at the top, looking down. But yeah, you're claiming you're looking up at other hills and calling that curvature. It's really convenient and
He
weird how
said
that
he
works.
looked down. He didn't. He said he looked down, not up.
Right, but that's in this scenario. But yeah, when we get into the talk of these observations, Jesse's claiming that he's looking upwards. How can you be on the top of a ball looking upwards at the top of a ball?
Oh, you mean when I'm at the beach?
Yeah, the beach.
No,
He likes me at
what?
the
You look
beach, boy.
outwards. You're not. Huh?
Go ahead.
Hello?
We hear you. So, just to clarify, I only claim that we're looking up at something below us when the viewer is down close to the water and the air is warmer than the water and the air is calm, and that it's not always that way. And that, of course, would be due to strong refraction gradients caused by the temperature difference between the air and the water. It does not happen when you're up high on a mountain looking at another mountain.
The refraction index from sea level to the top of the mountain is negligible in difference. So why would it change, Jesse?
It doesn't have to do with the change in the index of refraction along the line of sight. It has to do with the change of the index of refraction vertically through which the line of sight is going.
Right, and you're going to have to make an assumption about that because you can't measure it and confirm, right?
The point is, when you're high on a
Okay.
mountain looking at another mountain,
We love
viewing
when you
angle
do
should
this,
always
Jesse,
measure
when we
from
ask you
above the beginning.
questions and you just completely ignore them and try to find something else to pinpoint on, to wiggle your way out. We love the integrity.
Well, I like how you cut me off so I can't answer your questions.
You addressed that point real fast.
Well, the only argument the Globers right now have is the recent events of the 24-hour sun, but that's already getting debunked too.
Hey, Gakushi,
Somewhat.
would you be up for a 1v1 round table discussion with me about that? Because I think I have some
Sure.
information you haven't heard of.
Okay.
So, last year, my brother and I went up onto two mountain peaks that were 7.2 miles apart, each with a theodolite and a laser, and both mountain peaks were 6,000 foot elevation, and we measured the angle to each other at the same time. We both measured a downward slope to each other. We were both looking downward at each other. Now this matches the globe, but how would you explain that on a flat Earth?
I wouldn't have the slightest clue. I'm not a flat earther, but
Well, so you agree that this is something going for the globe then?
well, I don't agree because I have no knowledge of it and I'm not an expert in that field. So I would have to look into it, to what you're saying.
Well, but you can understand that two people at exactly the same height should look straight across at each other. A straight line should be level if the both ends are the same height, right?
Yes. Theoretically, yes.
Okay. Well, geometrically, if we don't accept geometry, then okay. But if geometry is true, then yes, it should be a straight level line. The fact that we both measured the other as being below us, that kind of points to a curved surface, doesn't it?
I mean, you're just using one specific example. So sure, in your example, it matches the globe, sure.
Okay, good. So we got one thing going for the globe.
Yeah.
Now, is there any similar experiment that goes for the flat that would support flat Earth?
It's measured on a flat surface. The Earth measurements are based on a flat Earth.
I don't understand. How does that measure flatness? Can you give an example like I did?
I mean, I would refer you to someone who explains it way better than me, and that's Nathan Oakley. But
He won't talk to me. I would, if you can arrange
yeah, just
it, if you can arrange it, I would be glad to. I've tried to talk to him. He just yells at me and mutes me, and I'm always polite to him, except that one time I called him something that. Well, anyway, never mind that. I thought it was I didn't know it was an offensive word, and I looked it up, and then I apologized to him. But anyway, I've always been polite to him, and he won't talk to me. So if you can get him to agree to a moderated roundtable discussion with me, I would be honored.
Well, I asked him about the 24-hour sun, and his answer was he already debunked the Gleason's map 10 years ago.
So maybe he's doesn't really believe flat Earth. He just wants to pay his mortgage.
No, he believes in flat Earth. He just doesn't believe in the simplified flat Earth that you guys want him to believe, right? Like the globe says, oh, you're a flat earther, you're all the same. You believe in Gleason's map and this and that. And the reality is, almost every other flat earther has different views on the shape of the Earth.
Okay, well, thank you.
I mean, that's the one thing, in fairness to your side, that's the one thing that the globe has, the flat Earth doesn't, is that globers are usually consistent. They all say the same thing. They all believe in the same thing. And you could argue, well, that's because they have a narrative. But
yeah, but at the end of the day, never mind a narrative. I can tell you if you tell me two mountain peaks, and you're going to go up to one of them and measure the vertical angle to the other, I can tell you what angle you're going to measure within a very reasonable margin, based on the globe model and geometry. Flat Earth can't do that.
How does that prove it's a globe, though?
Well, it just proves that it's a working model, and it proves that if the measurements are doing what they think they do, then it is a globe. And so far, no one has been able to present evidence that the measurements, that the laws of physics are different than we think, and therefore causing, in a way that would cause a flat Earth to measure as a globe. But you know what? If it's flat, but it measures in a globe every way that we measure it, it's not illegitimate for people to think it's a globe, right?
Sure.
I'll tag you with some other measurements I've done too.
I think I've heard it all, but go ahead.
Did you hear about my measuring the height of a 100-foot tall ship as it sailed across in a straight line in front of me, 7 miles away? Or 6 miles, I don't remember. No,
I haven't heard that one.
Okay, I just tagged you with it. Maybe it was, I don't remember the distance. It's been a while. But anyway, the numbers are all there. This ship called the Overseas Boston, who stands about 100 feet out of the water, was sailing along in a straight line, and I used my surveyor's theodolite to measure the elevation angle, and from that calculate the delta height relative to myself, assuming a flat Earth. And the ship appeared to start out at 20 feet above me, rise up to almost 40 feet above me, and then drop down to about 10 feet below me, or so.
Appeared to or measured at?
Well, I measured the angle to the ship, and then
You measured it above you by those different incremental feet that you said?
If you're going to cut people off, they're not going to want to talk to you, Fresh Grown.
I know. I just like to make sure we go point by point so it doesn't just get lost in the blur of just like that conscious stream that you can go on about. So sometimes you'll say ridiculous things and then blow right past it with something else as if we didn't hear that ridiculousness. So I just wanted to make sure.
Yeah,
You
there's
did
gotta.
measure. You measured
You
it
guys,
at 20 feet above you and 30.
there's got to be a better topic we can do. Sorry, Jesse, you've gone over this a billion times. We gotta gotten something better. What do you guys think? Something real.
Yeah.
Can
'cause
I?
I'm gonna do my routine with him.
How do I post the video here? Why can I post the video?